All right. Hi, everyone. Today we are going to talk about the nature of science. Okay. So the nature of science is basically what makes science unique from your other subjects. Okay. So what are the characteristics that make science science? All right. So I have my slide here to start off with what is science. Okay. So I'm going to refer back to the flowchart that we just made. Okay. So science, it's the culmination of those scientific practices, the nature of science, and the body of knowledge. Okay. So if we're looking for a more formal definition of science, it's our body of knowledge based on the study of the natural world. Okay. And so some essential characteristics is scientific inquiry. That's the same thing as those processes. Okay. So what processes did we use to actually learn that knowledge? And then it really focuses on the development of explanations. Okay, so science tries really hard to explain phenomenon happening in our natural world, and it has to be based off our experiments and our observations, and we have to use evidence and data. All right, so for today's notes, we're going to focus on nature of science, which is just like 1/3 of our scientific definition. So we made the flow chart. And we talked about some of the characteristics on the flowchart, others we didn't. I said we'd get to it in the notes, and so that day has finally arrived. So one part of science is composed of scientific theories and scientific laws, okay? And there's a difference. So a theory explains why natural phenomena occur, okay? In your notes, you should highlight, circle, underline, star, why. Theories are supported by many observations and experiments. Okay, so I'm going to say support. Okay. In our culture, we misuse the word theory a lot. A lot of times the word theory gets used like I have a guess. Like, I have a guess Ms. Wilcox is going to have Qdoba for lunch today. A lot of people would maybe substitute that, like, I have a theory Ms. Wilcox is going to have Qdoba for lunch. That is not really what a theory is, okay? When we use it that way in just like our everyday language, I think it helps us kind of get the wrong idea of a theory. So a theory, it is heavily supported by observations and experiments, okay? So there is a lot of evidence that makes us think that this theory is correct for the time being. Now, on the other side, let's look at a law. So a scientific law is just going to tell you what happens. Okay, so I'm going to add what over here. Okay, so laws tell you what happens. So it summarizes a set of observations about natural phenomena. Okay, that's the same thing as just what happens. Okay, so theories explain why something happens. Laws explain what happens. So if you think about like the law, let's do Newton's third law of motion. For every action, there's an equal and opposite reaction, right? It just says if I push on the wall pushes back on me. Okay, so it just says what, it doesn't explain why. And then in the middle of our Venn diagram, what do these share in common? So they are both based on hypotheses. Okay, so they are both heavily supported. And then they can both be used to make predictions, and they can both be revised. Okay. Remember when we made our flow chart, one of our characteristics of nature of science is tentative. Okay. As things change and as we learn more information, we can change, we can add, we can develop. So things can change. But that doesn't mean they're a shot in the dark. Okay. Theories are not random guesses. They are heavily supported. All right, so here are my notes. It's the same thing. So I just have theory. It's an explanation of natural phenomena. So it's supported by many observations over time. Some examples that we will learn about this year are going to be cell theory and evolution. And for laws, laws just describe those relationships. Okay, so they tell you what is going to happen. For this one, I have a law of conservation of matter. So that means if I'm going to do like a science, like a chemical reaction, whatever matter I start with is the same matter I'm going to end with. Okay, so things just don't magically appear or disappear. Okay, and laws, just remember, they don't explain why. They just explain what. So this brings me to my question. Will a theory ever become a law? So go ahead and pause the video, and I want you to think about this for a minute. All right, so I left off with asking you the question, will a theory ever become a law? And the answer to this is no, okay? A nice, large, bold no. And the reason why, theories and laws are just fundamentally different, okay? A theory has been always with the goal of explaining why something happens, and a law has always been built upon explaining what happens, okay? So these two will never turn into each other. And I like to point that out because it seems like sometimes people think theories will eventually be proven true and will somehow become a scientific law. And that's not the case, okay? So theories, they're always going to be tentative. They can always change, okay? And they will never become a law. They're just fundamentally different. All right, so then when we're talking about the nature of science or characteristics of science, we're going to talk about what is it that science can do and what is it that science can't do. So we're going to start with can't. So there are some things that science just can't do. So some of those, let me change my color here, are like opinions. Okay, so science can't answer opinion questions. Okay, so I'm going to put a line through it. So we can't answer opinions. So that means like who creates the best milkshake in town, okay? You can't actually drive around to all the different restaurants in town that make a milkshake because it's an opinion, right? What I might classify as a delicious milkshake is going to be different than what you might, okay? So we can't do science to answer that. Science also can't answer questions that are supernatural. So science only focuses on our natural world. So we're only looking on the natural world, what we can observe. Okay, so we don't do anything supernatural. I want you guys to brainstorm. Can you think of anything else science cannot do? And while we're on the topic of what science can and can't do, I like to just bring up a little branch called pseudoscience. So let's just look at the word pseudo. Okay, what does pseudo mean? If you don't know, go ahead and pause the video and Google, what does pseudo mean? All right, so hopefully you're thinking of words like fake, not real, sham. Pseudoscience, they're just areas of study that try to imitate science. Okay, these aren't actually science. Okay, but they're advertised like they are real science. Okay, so they're driven by cultural and commercial goals, and they don't lead to any new knowledge. So whenever we're studying science, science is always looking for new knowledge. Pseudoscience doesn't ever lead to new knowledge. It typically is just trying to get you to like buy into a product or something. So some common examples of pseudoscience are astrology, horoscopes, psychic readings, tarot cards. There's a whole bunch. Now, I'm not trying to say that you can't enjoy reading your horoscope, okay? You can definitely enjoy looking at your horoscope, okay? You can enjoy hearing astrology stories. I'm just saying that they're not science, okay? So I'm not saying they're not enjoyable. I'm just saying they don't actually follow the nature of science. So what you learn from like astrology or your horoscopes are not scientific fact. So that brings us to what can science actually do? So science can make observations and draw conclusions. Science can expand our knowledge. Science challenges accepted theories. Okay? Science questions results. It tests claims and it undergoes peer review. So basically, what that means is science is really argumentative. Okay? For those of you who love to argue and love debate, you will love science. So everything in science is up for debate and it's up for review. So whenever a scientist thinks that they have established a new theory, other scientists are going to challenge them. Okay? They're going to look at what they did. They're going to challenge. And they're going to question the results. Scientists are skeptics. Okay? So I'm going to question your results. I'm going to make sure that the results you think you're getting, I agree with those. I'm going to test your claim. Just because you say your experiment works, I'm going to test it and see if it works for me where I am. And then finally, science undergoes peer review. Okay? So a peer would be someone who has the same qualifications as you. Okay, so another scientist who's also in your same field, and they're going to look at your procedures and results of an experiment, and they're going to evaluate it and make sure you got your procedures and your results in a valid way. So whenever you are reading science, it's been challenged, it's been vetted, and it's undergone peer review, which to some level gives it some validity. Now remember, it can be tentative. When technology changes, we can always learn more. But our scientific facts, they have been well vetted, and they're the best we can do with what we have. All right, and then finally, by understanding more of the nature of science, we're hoping to bring science into your everyday life. So as we talked about when making the flowchart, a new kind of buzzword that you might hear is scientific literacy or science literate, okay? So that just means someone has the ability to use scientific information to make personal or societal decisions, okay? So when you make a decision, you're gonna actually process those scientific facts first to help you make those choices, okay? And a benefit of science literacy is you become an educated consumer on important issues, okay? So let's say you want to, well, actually, let me back up. So here's our example of world issues, and these are not all of them. These are just some of them, right? So drugs, alcohol, tobacco, AIDS, mental illness, cancer, heart disease, eating disorders, COVID-19, GMOs, genetic engineering, cloning, genetic screening, euthanasia, cryonics, okay? So these are a lot of world issues that you'll have to maybe at one point make a personal decision or a societal, you might have to vote for some of these. And so rather than just polling what you see on your social media or just your own opinion, so by being scientifically literate, you're gonna actually use the scientific facts on these topics to help make those decisions.